Alright, so hey everybody, so today we're talking about four types of relations. I guess before we start talking about the four types of relations, we should define what a relation is. So a relation is any relationship between two, doesn't have to be quantities, but two variables, two things, that has a beginning set and an ending set. And so a lot of times when we say beginning set and ending set, you'll hear this called by different names like inputs and outputs, or like domain and range, independent variable and dependent variable. All of these words kind of mean the same thing in different contexts, but we're talking about beginning set and ending set, or domain and range. And the way I've shown the beginning set and ending set in each of these different relations is with a mapping. So the first box shows the inputs or the domain, and the second box shows the outputs or the range. So this is your beginning set and your ending set. And if you notice in the mapping, there's always an arrow at the end of each of these lines. It's not just a connection between two numbers, it's actually a direction from beginning set to ending set. So these relations are relationships that have a beginning set and ending set, and they come in four types. So these are the four types up here. We have many to one, one to one, one to many, and many to many. And this lesson is leading up to another lesson about what functions are. Functions are two of these types as a special kind of relation, a relation. And this one, many to one, this is a function, and one to one, this one is a function, and we'll talk about that more later on. Okay, so let's start looking at some of these types of relations. So let's start with many to one. So this information in the mapping and the information in the graph are showing the same information, just in a different way. Graphical representation represented by a mapping, and here represented algebraically or symbolically, but they all represent the same information. So why this particular relation is many to one can be seen in the mapping right here. So what this is saying is this spot right here. What this is saying is that when you put -1 into the function, into this relation, you square it, -1 squared is equal to 1. So when you put -1 into the function, or into the relation, what you're going to get out is +1. When you put +1 in, you get the same thing out, the same output. That's many inputs producing the same output, many to one. This is why we call it many to one. And the same thing can be seen in the graph. So on the x-axis, on the horizontal axis, this is where we plot domain, or this is our inputs. And on the vertical axis, we plot our outputs, or range. So when you input, the graph is showing you that when you input 1 to the function, what comes out is +1. Also, if you put -1 into the function, what comes out is +1. Many inputs that are going to the same output. So this is why we call this relation many to one. And this one, it turns out, is a function. And the reason why is with a function, a function is when there's only one output from each input. And so you have to know where you're going with a function. If you know where you're going, then it's a function. One output from each input. So something to keep in mind as we go through the relations, okay? And you check and see if that makes sense, if it's matching up with what you're hearing. Okay, second type of relation, one to one. So this, and you can see kind of how that plays out in the mapping here, one to one. One input is going to only one output, one to one correspondence, and only one output only has one input for it also. So when you put 0 in, you get 0 out, and there's no other inputs that produce 0, and there's no other outputs that are associated with 0. It's a one-to-one correspondence. Each input gets its own output, and each output gets its own input. That's one-to-one. And you can see it play out here in the graph. When you put 1 into this function, what you're going to get out is 2. And here's the symbolic representation of it. All of our inputs are being multiplied by 2. So when every time you put a new output in here, you're going to get a new input in here. Every time you do that, you're going to get a new output. And that's what's shown here on the graph. So if you put a new input, you're going to get a new output. I don't think I drew that to the right place. Oh yeah, I think I did. Yeah, okay. So, and this one also is a function. One output from each input. Do you know where you're going? If you put an input in, do you know exactly what you're going to get out? Yes? Then it's a function. Okay, let's look at two relations that are not functions. this have some ambiguity. When you put an input in, you don't know what you're going to get out. So for example, look here at the graph first. If you put 1 into this relation, then you're going to get 1 out, or you're going to get -1 out. So that's one input that has 2 outputs. When you put 1 into the relation, you don't know if you're going to get 1 out or you're going to get -1 out. That ambiguity is not allowed for functions. That's what makes this not a function. One input having 2 outputs. Remember, a function is when there's only 1 output from each input. This is 2 outputs from one input. And this is 1 input going to many outputs. So it's not a function, and that's the type of relation that it is. And the last one's not a function either. This one is called many-to-many. And this is supposed to be a circle, but it's poorly drawn. And let's look at what happens when we put... oh, sorry, I didn't give you a symbolic representation of this one. It's okay. Let's look at, based on the graph, what happens when you put inputs into this relation. So say you put 1 into this relation. What's going to happen is that maybe you get this out, which I just kind of approximated as 1 3/4 for your output. Just kind of pretend, I guess. And maybe you get this out, right? So first of all, we know it's not a function because we're getting 2 outputs from the same input. But the difference between this one and this one, because they seem pretty similar so far, the difference is, though, if you put -1 into this relation, you end up with the same output. +1 3/4, -1 3/4. So you put in this input is mapped to 2 outputs, and this input is mapped to those very same outputs. So this is how we end up with a mapping that looks kind of confusing like this one, where we have 1 input going to multiple outputs, and also some of these outputs are getting multiple inputs that produce them. So this is kind of a combination. Many-to-many is kind of a combination of 1-to-many and also many-to-one, and that's what makes it many-to-many. And again, this one is not a function because we have this ambiguity of when you put in an input, we don't know exactly what's going to come out. Okay, that's the end of the story today.